ServSafe Manager 8th Edition, Chapter 11, Safe Facilities and Equipment. Inside this chapter, we'll discuss designing a safe operation, considerations for other areas of the facility, equipment selection, installing and maintaining kitchen equipment, and utilities. Our key terms are porosity, resiliency, coving, NSF International, potable, booster heater, cross connection, backflow, back siphonage, vacuum breaker, and air gap. Our learning objectives. After completing this chapter, you should be able to describe the proper operation of facilities and equipment, explain requirements for installing equipment, identify requirements for hand washing sinks and accessibility, list requirements for proper garbage and biohazard removal, and identify whether or not equipment meets approved standards for food service equipment. Cafe owners stopped from opening. The new owners of a small breakfast cafe were all set for their pre-opening inspection by the local regulatory authority. The owners recently purchased the cafe, which had sat vacant for a number of years. After the inspection, they were shocked to find out they would not be able to open. The inspector found a number of violations. Several floor tiles were cracked and a few ceiling tiles were missing. The coving between the floor and the wall had also come away from the wall in several places. The exhaust hoods in the kitchen were extremely dirty, and there was buildup of grease on certain areas of the walls and ceilings. There were also problems with the equipment in the cafe. Some of it was household equipment. The wooden cutting boards had several large cracks. There were also some problems in other areas. Only the cold water worked at the hand washing sink in the restrooms, and the dumpster behind the cafe was missing a lid. The inspector told the owners that he would be back to inspect the cafe again once they had fixed the problems. The question here is, what do the owners need to fix in order to open for business? 11.1, Designing a Safe Operation. Many restaurant managers dream of designing their own operation from the ground up. There are a million decisions to be made and many factors to be considered. Menu offerings and service style are two important examples. A buffet operation will have very different requirements compared to a quick service restaurant or a fine dining operation. Not every manager will have the opportunity to design from the blank slate, but every manager really needs to understand the basics of the design of an operation. Poor decisions in everyday issues, such as purchasing and installing kitchen equipment, can prove costly. The wrong ventilation system could lead to a grease fire. An improperly installed cooler could result in thousands of dollars of lost product. Most importantly, poorly designed operations can result in unsafe food. When designing or remodeling a facility, consider how both the building and its equipment will be kept clean. Poorly designed areas are generally harder to clean and can become a breeding ground for pathogens. Food passing through these areas runs a much higher risk of contamination. This chapter focuses on 4 topics related to the safe layout and design of equipment and facilities: designing and arranging equipment and fixtures to comply with sanitation standards, selecting wall, floor, and ceiling materials that are easier to clean, designing utilities to prevent contamination and make cleaning easier, and managing garbage correctly to avoid contaminating food and attracting pests. Construction plan review. Before starting any new construction or a large remodeling project, you must check with your regulatory authority. You will need approval of your construction plans before construction begins. This mandatory regulatory review of the plans has several benefits. It ensures the design meets regulatory requirements. It ensures a safe flow of food. It may save time and money. And it assures that contractors are constructing the facility correctly and approved equipment is being used. Here, this photo on the left, careful planning is critical before starting new construction or remodeling. The local regulatory authority should be contacted. In addition to submitting your construction plans to the regulatory authority, you should also check with your local building department to see what is required. A well layout. A well-designed kitchen will address the following factors. Workflow. Establish a workflow that will minimize the time food spends in the temperature danger zone. It should also minimize the number of times food is handled. For example, locate storage areas near the receiving area to prevent delays in storing food, and keep prep tables near coolers and freezers for the same reason. Contamination. A good layout will minimize the risk of cross-contamination. Place equipment in a way that will prevent splashing or spilling from one piece of equipment onto another. For example, avoid placing a dirty utensil table next to the salad prep sink. Equipment accessibility. Hard to reach areas are less likely to be cleaned. A well-planned layout will ensure the equipment is accessible for cleaning. Here, this photo shows a prep line and coolers and freezers. A simplified layout of a kitchen showing workflow. The layout shows food storage areas located near the receiving area, which can prevent delays in storing food. It also shows prep tables located near coolers and freezers for the same reason. For materials for interior construction, when selecting materials for interior construction, the most important consideration is how easy the operation will be to clean and maintain. Sound, absorbent surfaces that resist grease and moisture will reflect lightly will likely create an environment acceptable to the regulatory authority. Flooring. Each area of your operation has its own flooring needs. Flooring should be smooth, durable, non-absorbent, and easy to clean. It should also resist wear and help prevent slips. Once installed, flooring should be kept in good condition and replaced if damaged or worn. If standing water occurs due to spraying or flushing the floors when cleaning, remove it as quickly as possible. The flooring's porosity is another important factor. Porosity is the extent which a material will absorb liquids. Avoid high porosity flooring. Its absorbency often makes it ideal for pathogen growth. High porosity flooring can also cause people to slip or fall. It often deteriorates quickly as well. To prevent these problems, use non-absorbent flooring in the following areas: walk-in coolers, prep and food storage areas, dishwashing areas, restrooms, and dressing and locker rooms. Here, this photo on the left, this food handler is mopping a kitchen floor covered with vinyl tile. 2 tiles appear to have been replaced. Non-porous resilient flooring. In most areas of the operation, non-porous resilient flooring is the best choice. Resiliency means a material can react to a shock without breaking or cracking. Non-porous resilient materials such as vinyl or rubber tiles are relatively inexpensive. They are also easy to clean and maintain. If individual tiles break, they can be replaced easily. They can also handle heavy traffic and resist grease and alkalis. However, this type of flooring does have disadvantages. Sharp objects can easily damage it. It also tends to be slippery when wet. It is usually a poor choice for dining rooms or public areas. It is more practical for break rooms, staff dressing rooms, and food service offices. See Table 11A for characteristics and recommended uses of non-porous resilient flooring. Here, Table 11A. Characteristics of non-porous resilient flooring. For rubber tile, we would use it in kitchens and restrooms. For durability, it's less durable and less resilient to grease and alkalis. Its advantages are that it's non-slip, resilient, and easy to clean. And its disadvantages are it can only be used in a moderate traffic area. For vinyl sheet flooring, we would use it in offices, kitchens, and corridors. Its durability is less resistant to grease and alkalis. Its advantages are it's very resilient and easy to clean. Its disadvantages are it can only be used in light or moderate traffic areas. For vinyl tile, where we would use it is offices and staff restrooms. Its durability wears out too quickly with high traffic, and its advantages are very resilient and easy to clean. Its disadvantages is it requires waxing and machine buffing. Hard surface flooring. Because it is durable and non-absorbent, hard surface flooring is often used in food service operation. These types of flooring, especially quarry and ceramic tile, are excellent for public restrooms and high dirt areas. Still, these flooring materials have their disadvantages. They may crack or chip if heavy objects are dropped on them. They do not absorb sound, and they are expensive to install and maintain. Finally, hard surface flooring is somewhat difficult to clean. While most hard surface floors, especially marble, can be slippery, unglazed tiles can provide a hard, slip-resistant surface. See Table 11B for characteristics and recommended uses of hard surface flooring. Table 11B, marble or terrazzo flooring we would use in public quarters, dining rooms, and public restrooms. Its durability is wear resistant. Its advantages is it's non-porous and good appearance, and its disadvantage is it's non-resilient, heavy, expensive, requires special care, and it's difficult to install. For quarry tile, kitchen service, we would use it in kitchens, service areas, dishwashing and receiving areas, offices, restrooms, and dining rooms. It's very durable, wear resistant. Its advantages are that it is non-porous, and its disadvantages are it's non-resilient, heavy, expensive, slippery when wet, and less abrasive is added. For wood, we would use it in offices and dining rooms. For its durability, it's durable in lower traffic areas. Its advantages are good appearance and sound absorption. And its disadvantage, it requires frequent polishing and periodic refinishing to maintain surface qualities. For carpeting, carpeting is a popular choice for certain areas, such as dining rooms, because it absorbs sound. However, it is not recommended in high dirt areas such as wait staff service areas, tray and dish drop-off areas, beverage stations, and major traffic aisles. Carpet can be maintained by simple vacuuming, and areas prone to heavy traffic and moisture will require routine cleaning. You can also purchase special carpet for areas where sanitation, dirt, moisture, and fire safety are concerns. Special flooring needs. Use non-slip surfaces in traffic areas. Non-slip surfaces are ideal for the entire kitchen as well, because slips and falls are a potential hazard. For safety reasons, rubber mats are allowed in areas where standing water may occur, such as in a dish room. When scrubbing floors, pick up rubber mats and clean them separately. Coving is required in operations when using resilient or hard surface floor materials. Coving is a curved, sealed edge placed between the floor and the wall to eliminate sharp corners or gaps that will be impossible to clean. The coving tile or strip should adhere tightly to the wall. This will help eliminate hiding places for insects. It will also prevent moisture from deteriorating the wall. This photo on the left ceramic coving placed between the floor and the wall of the establishment. Finishes and interior walls and ceilings. Interior finishes are the materials used on the surface of an operation's walls and ceilings. As with flooring, these finishes need to be smooth, non-absorbent, durable, and easy to clean. Consider the location when selecting finishes for walls and ceilings. A material that might be suitable in one area may be a poor choice for another. Walls and ceilings in prep areas should be light in color to distribute light and make it easier to spot dirt when cleaning. They should also be kept free of cracks, holes, and peeling paint. The best wall finish in cooking areas is ceramic tile. However, it needs to be monitored for grout loss and regrouted when needed. Stainless steel is used occasionally when it is durable and moisture resistant. The most common ceiling materials are acoustic tile, painted drywall, painted plaster, and exposed concrete. Wall and ceiling support structures, studs, joists, and rafters, as well as pipes, should not be exposed unless finished and sealed for cleaning. Flexible materials such as paper, vinyl, and thin wood veneers are often used for walls and ceilings. Vinyl wall coverings are popular because they are attractive, relatively inexpensive, easy to clean, and durable. They are also rated for flammability by testing agencies. Plaster or cinder block walls that have been sealed and painted with oil-resistant, easy-to-wash, glossy paints are appropriate for dry areas of the facility. This photo on the right, this employee is using a scrub brush to clean a ceramic tile wall in a cooking area. Knowledge check. Pause and answer these questions. Which three factors will be addressed by a well-designed kitchen layout? Question 2. Name 4 qualities that flooring should have for most areas of the operation. Pause and ask yourself these questions. Answer them. 11.2. Considerations for other areas of your facility. Once you have a general layout of how the kitchen should be and the materials to complete it, you need to think about other areas of the facility. There are so many to consider, from dry storage to hand washing stations to sinks and restrooms, and sometimes even locker areas for employees. And these areas need to be well thought out. You do not want to put sinks in inconvenient places or require guests to walk through food prep areas to get to restrooms. These types of mistakes can cause contamination and make food unsafe. As a manager, you want to ensure you have all the right items in the right places in order to maintain food safety. Dry storage. Construct dry storage areas with easy to clean materials that allow good air circulation. Shelving, tabletops, and bins for dry ingredients should be made of corrosion-resistant material or food-grade plastic. Any windows in the dry storage area should be frosted glass or shades. Direct sunlight can increase the area's temperature and affect food quality. Steam pipes, water lines, and other conduits do not belong in a well-designed dry storage area. Dripping condensation or leaks in overhead pipes can promote pathogen growth in normally stable items, such as crackers, flour, and baking powder. Leaking overhead sewer lines can also contaminate food. Hot water heaters or steam pipes can raise the area's temperature levels. Dry food is also susceptible to attack by insects and rodents. Cracks and crevices in floors or walls should therefore be filled. Doors leading to the building's exterior should be self-closing, and screens for windows and doors should be 16 mesh to the inch without any tears or holes. The photo on the left, this dry storage room was set up with good air circulation in mind, as shown by arrows representing air movement. Hand washing stations. Hand washing stations should be put in areas that make it easy for staff to wash their hands often. Hand washing stations are required in restrooms or directly next to them, and in areas used for food prep, service, and dishwashing. Hand washing sinks must be used only for hand washing and not for any other purpose. And to prevent cross contamination, make sure adequate barriers are present in hand washing sinks, or that there is adequate distance between hand washing sinks and food contact surfaces so that water cannot splash on these items. The photo on the left, a hand washing station, a hand washing sink with a splash guard for preventing the cross contamination of nearby food contact surfaces. Make sure these stations work correctly and are well stocked and maintained. They must also be available at all times. This means hand washing stations cannot be blocked by portable equipment or stacked full of dirty kitchenware. This photo on the right, this hand washing sink has been blocked from use because of dirty pans stacked inside. Hand washing sinks must be used only for hand washing and not for any other purpose. If we see Table 11C for requirements at a hand washing station, and some jurisdictions allow the use of automatic hand washing facilities in an operation. Check with your local regulatory authority for more information. Requirements at a hand washing station are hot and cold running water. The water must be drinkable and meet temperature and pressure requirements. Temperature of at least 85 degrees. Soap. The soap can be liquid, bar, or powder. It needs a way to dry your hands. Disposable paper towels or continuous towel systems that supplies the user with a clean towel can be used. Hands can also be dried with a hand dryer using either warm air or room temperature air delivered at high velocity. Your hand washing station must have a garbage container. Garbage containers are required if disposable paper towels are used. And your hand washing station must have signage. A clearly visible sign or poster must tell staff to wash hands before returning to work. For sinks, to prevent cross-contamination, staff must use each sink in the operation for its intended purpose. Hand washing sinks are for hand washing. Prep sinks are for preparing food. Service sinks are for cleaning mops and disposing of wastewater. At least one service sink or curbed drain area is required for disposing of dirty water. The photo on the left, an employee is dumping dirty mop water into a curbed floor drain. In the operation, so many sinks. The number of different sinks found in a restaurant or food service operation can be surprising. Each sink has a particular job in the operation and should be used for only that job, or you risk making food unsafe. For example, dumping mop water in a prep sink normally used for washing salad greens could contaminate food. Hand washing sink. Hand washing stations will be used by every person working in your operation. These sinks are typically located in or directly next to restrooms. They are also found in areas used to prep food and also in service areas. The key to ensure that hand washing stations are located in convenient areas. This will make it easier for staff to wash their hands frequently. The prep sink. Prep sinks are used in food preparation. If you need to rinse produce or get a gallon of water to make soup, the prep sink is the place to do that. They tend to be larger than hand washing sinks, and the size and number of compartments will vary depending on the operation. Prep sinks are most often located in kitchen areas. 3-compartment sinks. 3-compartment sinks are typically used for cleaning and Sanitizing larger items. If an item is too large to fit in a dishwashing machine, it can be cleaned and sanitized here. This sink has 3 separate compartments as well as drain boards. The separate compartments are for washing, rinsing, and sanitizing. The service sink. Service sinks are similar to the utility sinks found in many homes. They should not be used for food prep or other food related tasks. These sinks are used for tasks related to cleaning the operation, such as cleaning mops and disposing of wastewater. They are often found in janitorial areas of the operation away from food prep areas. Curbed floor drain. Curbed floor drains may not technically be sinks, but they have a job that overlaps with the service sink. If you need to dispose of wastewater, such as a heavy bucket of mop water, a curbed floor drain is handy. Their location on the floor means that staff doesn't have to lift heavy buckets. The curbed sides help maintain the wastewater. Restrooms, if possible, provide separate restrooms for staff and customers. If this is not possible, the operation must be designed so patrons do not pass through prep areas to reach the restroom. Otherwise, they could contaminate food or food contact surfaces. Restrooms should be convenient, sanitary, and have safe closing doors. They must be adequately stocked with toilet paper. Garbage containers must be provided if disposable paper towels are used. Women's restrooms need covered garbage containers for disposing of sanitary supplies. Dressing rooms and lockers. Dressing rooms are not required. If available, they should not be used for food prep, storage, or utensil washing. Lockers should be located in a separate room or one where food, equipment, utensils, linens, and single service items cannot be contaminated. Premises. Parking lots and walkways should be graded so that standing pools of water do not form. They should also be surfaced to minimize dirt and blowing dust. Concrete and asphalt are recommended for walkways and parking lots. Gravel, while acceptable, is not recommended. Customer traffic throughout prep areas is prohibited. Although guided tours are allowed, do not allow the premises to be used for living or sleeping quarters. Knowledge check. Pause and answer these questions. Why should windows on dry storage areas have frosted glass or shades? Question 2. Why must staff use each sink in an operation for its intended use? 11.3 Equipment selection. Choosing equipment can be a difficult task, but it is certainly an important one. For those who are new to the industry, the choices can seem overwhelming. Most people will be familiar with appliances used at home, such as simple dishwashing machines and kitchen sinks. But in a restaurant or food service operation, these choices for equipment are much more complicated. For example, coolers can range in size from tiny, under counter units used for a bar area up to walk-in units as large as a suburban garage. And commercial equipment must also meet different standards than items intended for home use. Choosing and using the right equipment can mean the difference between food being safe and unsafe. Equipment standards. Food service equipment must meet specific standards if it will come in contact with food, such as being smooth, easy to clean, durable, and resistant to damage. Organizations such as NSF International have developed standards like these for the sanitary design and construction of food service equipment. They also certify equipment that meet these standards. Other organizations classify equipment or evaluate it to ensure that it meets the standards developed by others. These organizations must be accredited by the American National Standards Institute. When purchasing equipment, look for the NSF mark, the ULEPH classified mark, or the ETL sanitation mark. These indicate the equipment has been certified or classified for sanitation under the ANSI accredited program. Only commercial food service equipment should be used in operations. Household equipment is not built to withstand heavy use. This photo on the right, an NSF logo on a cutting board indicates the equipment is approved for use with food. Dishwashing machines. Dishwashing machines vary widely by size, style, and method of sanitizing. High temperature machines sanitize with extremely hot water. Chemical sanitizing machines use a chemical solution. The following machines are common in food service operations. There are single tank sanitary rack machines with doors. This machine holds a sanitary rack of tableware and utensils. Items are washed by detergent and water from below and sometimes from above. The wash cycle is followed by a hot water or chemical sanitizer final rinse. There's a conveyor machine. With this machine, a conveyor moves racks of items through the various cycles of washing, rinsing, and sanitizing. The machine may have a single tank or multiple tanks. Carousel or circular conveyor machines. This multiple tank machine moves tableware and utensils on a peg type conveyor or on racks. Flight type. This is a high capacity multiple tank machine with a peg type conveyor. It may also have a built-in dryer. Batch type dump. This sanitary rack machine combines the wash and rinse cycles in a single tank. Each tank is timed, and the machine automatically dispenses both the detergent and the sanitizing chemical or hot water. Wash and rinse water are drained after each cycle. Recirculating door type non-dump machines. This sanitary rack machine is not fully drained of water between cycles. The wash water is diluted with fresh water and reused from cycle to cycle. For dishwasher and installation guidelines, consider these guidelines when selecting and installing dishwashers. For installation, dishwashers must be installed so that they are reachable and conveniently located. The installation must also keep utensils, equipment, and other food contact surfaces from being contaminated. The machine should be raised at least 6 inches off the floor to permit easy cleaning beneath. Always follow the manufacturer's instructions when installing, operating, and maintaining a dishwasher. For plumbing, water pipes to the dishwashing machine should be as short as possible to prevent the loss of heat. In chemicals, we use detergents and sanitizers approved by a regulatory authority. In settings, purchase dishwashers that can measure the following: water temperature, pressure, cleaning and sanitizing chemical concentration. Information about the correct settings should be posted on the machine. This photo on the left, the label on the dishwashing machine displays parameters for proper operation, including wash and final rinse temperatures. For the thermometer, the machine's thermometer should be located so it is readable with a scale in increments no greater than 2 degrees Fahrenheit. For cleaning, dishwashers should be easy to clean. They should be cleaned as often as necessary and follow the manufacturer's recommendations and local regulatory requirements. For 3-compartment sinks, many operations use 3-compartment sinks to clean and sanitize items manually in the operation. Purchase sinks that can accommodate large equipment and utensils, and have other ways of cleaning items as well, such as cleaning a large piece of equipment in place. For coolers and freezers, there are several types of coolers and freezer units. The two most common are walk-in and reach-in coolers and freezers. The doors should withstand heavy use and close with a slight nudge. A drain must be provided and maintained for disposal of condensation in defrost water as well. Correctly plumbed Indirect drains can be used in a walk-in cooler. You can minimize any excess condensation by maintaining a flush mounting floor sweep gasket under the door. So put a gasket on the door. Considerations when purchasing coolers and freezers. In addition to sanitation standards discussed in this chapter, consider these factors when purchasing a cooler or freezer unit. For installation, make sure walking units can be sealed to the floor and wall. They should offer no access to moisture or rodents. For reach-in coolers, purchase reach-in cooler or freezer units with legs that elevate them 6 inches off the floor. Otherwise, mount and seal them in a masonry base. Caster wheels are often preferred or required by regulatory authorities. They make it easier to move the unit for cleaning. In temperature, make sure the unit meets the temperature requirements of the food you store. Built-in thermometers should be easy to locate and read, and they should also be accurate within 3 degrees Fahrenheit. This photo on the right shows a reach-in cooler with caster wheels that make it easier to clean underneath. This photo on the right shows a blast chiller for cooling food quickly. Blast chillers and tumbler chillers. Blast chillers cool food quickly. Many can cool food from 135 degrees to 37 degrees within 90 minutes. Most units allow the operator to set target chill temperatures and monitor the temperatures of food throughout the chill cycle. Once chilled to safe temperatures, the food can then be stored in conventional coolers or freezers. Tumble chillers cool food quickly as well. Prepackaged hot food is placed into a drum that rotates inside a reservoir of chilled water. The tumbling action increases the effectiveness of the chilled water in cooling the food. Cook to chill equipment. Some operations prep food using a cook to chill system. By this method, food is partially cooked, rapidly chilled, and then held in refrigerated storage. When needed, the food is simply reheated. A cook to chill unit is an integrated piece of equipment that can cook, cool, and reheat food. Cutting boards. Many regulatory authorities allow you to use the use of either wooden or synthetic cutting boards. If the regulatory authority allows wooden cutting boards and baker's tables, they need to be made from a non-absorbent wood such as maple. They need to be non-toxic and free of cracks and seams as well. Knowledge check. Pause and answer these questions. Question 1. When comparing dishwashing machines, what is the difference between high temperature machines and chemical sanitizing machines? Stop and answer this question. Question 2. Name 2 pieces of equipment that can cool food quickly. Stop and answer these questions. 11.4 Installing and maintaining kitchen equipment. When installing and maintaining equipment in a commercial kitchen, the most important thing to keep in mind is the safety of the food. A critical aspect of correct installation is simply ensuring that the equipment is easy to clean and easy to clean around. If it is not, then there is a risk that staff may not properly maintain the equipment. Incorrect installation can result in a failure to meet local inspection standards. So can dirty or improperly maintained equipment. Sanitary equipment should be easy to clean and easy to clean around. The photo on the left, an employee is mopping underneath a dishwasher that has been installed on legs, making it easier to clean underneath. Installing kitchen equipment. Follow the manufacturer's directions when installing equipment. Also, check with your regulatory authority for requirements. In general, sanitary equipment should be installed as follows. For floor-mounted equipment, put floor-mounted equipment on legs at least 6 inches high. Another option is to seal it to a masonry base. For tabletop equipment, Put tabletop equipment on legs at least 4 inches high or seal it to the countertop. So the photo on the left, an ice machine installed on legs 6 inches from the floor to facilitate cleaning underneath. And the photo on the right, a tabletop milk dispenser mounted on legs 4 inches from the tabletop to facilitate cleaning underneath. Also, seal all cracks or seams to prevent food buildup or pests. However, do not use sealant to cover wide gaps from faulty construction or repairs. Any gaps should be correctly repaired before equipment is installed. For maintaining equipment, once you have installed equipment, make sure it is maintained regularly by qualified people. Also, set up a maintenance schedule with your supplier or manufacturer. Check equipment regularly to be sure it's working correctly. Knowledge check. Pause and answer these questions. Question 1. What are the requirements for installing floor-mounted stationary equipment? Question 2. What are the requirements for installing tabletop stationary equipment? Pause and answer these questions. 11.5 Utilities. An operation uses many utilities and building systems. Utilities include water, electricity, gas, sewage, and garbage disposal. Building systems include plumbing, lighting, and ventilation. There must be enough utilities to meet the needs of the operation. In addition, the utilities and systems must work correctly. If they do not, the risk of contamination is greater. It is always the goal to keep food safe. Even something as simple as correct plumbing is essential to food safety. For example, an incorrectly installed soda machine could lead to toxic metal poisoning of carbonated water. If carbonated water is allowed to reach copper water pipes. A low water pressure event could allow contaminated water into an ice machine. And when it comes to electrical systems, an overloaded circuit could cause a cooler to fail. This could result in time temperature abuse and the loss of all product. Keeping utilities and systems functioning correctly is critical to food safety. For our water supply, each regulatory authority establishes standards for water in its jurisdiction. Only water that is drinkable can be used for prepping food and come in contact with food contact surfaces. Drinkable water is called potable water. This water may come from the following sources: an approved public water main, private water sources that are regularly tested and maintained, closed potable water containers, and water transportation vehicles. If your operation uses a private water supply, such as a well, rather than an approved public source, check with your regulatory authority for information on inspections, testing, and other requirements. Non-public water systems should be tested at least once a year. The report should also be kept on file in the operation. Regardless of where your water comes from, you should know how to prevent plumbing issues that can affect food safety. If your operation has an on-site septic system, make sure it is properly tested and maintained. And for hot water, providing a continuous supply of hot water can be a problem for many operations that serve the public. Evaluate water heaters often to make sure they can meet peak demands, and consider how quickly the heater produces hot water as well. Also, take into account the size of the holding tank and the heater's location in relation to sinks and dishwashing machines. Most general purpose water heaters will not heat water to temperatures required for hot water sanitizing. You might then need a booster heater to maintain water temperature. Many dishwashing machines now come with booster heaters. For plumbing, incorrectly installed or poorly maintained plumbing has been implicated in outbreaks of typhoid fever, hepatitis A, neurovirus, and other illnesses. For this reason, only licensed plumbers should install and maintain your plumbing. Cross connections. The greatest challenge to water safety comes from cross connections. A cross connection is a physical link between safe water and dirty water, which can come from drains, sewers, or other wastewater sources. This photo on the right, this illustration displays an example of back siphonage with a hose connected at one end to a running sink faucet and the other submerged in a mop bucket being filled with water. Contaminated water is being pulled into the water supply by back siphonage. A cross connection is dangerous because it can lead to backflow. Backflow is the reverse flow of contaminants through a cross connection into a drinkable water supply. Backflow can be the result of pressure pushing contaminants back into the water supply. It can also happen when high water use in one area of an operation creates a vacuum in the plumbing system that sucks contaminants back into the water supply. This is called back siphonage. A running faucet below the flood rim of a sink is an example of a cross connection that can lead to back siphonage. A running hose and a mop bucket is another example. Backflow prevention. The best way to prevent black backflow is to avoid creating a cross connection. Some ways to do this include: do not attach a hose to a faucet unless a backflow prevention device, such as a vacuum breaker, is attached. A vacuum breaker is a mechanical device that prevents back siphonage. It does this by closing a check valve and sealing the water supply line shut when water flow has stopped. Other mechanical devices are used to prevent backflow. These include double check valves and reduced pressure zone backflow preventers. These devices include more than one check valve for sealing off the water supply. They also provide a way to determine if the check valves are operational. This photo on the right with the red circle, a vacuum breaker connection to a faucet. Backflow prevention devices must be checked periodically to make sure they are working correctly. This must be done by a trained and certified technician, and the work must be documented. Always follow local requirements and manufacturer's recommendations. The only sure way to prevent backflow is to create an air gap. An air gap is an air space that separates a water supply outlet from a potentially contaminated source. A sink that is correctly designed and installed usually has two air gaps. One is between the faucet and the flood rim of the sink. The other is between the drain pipe of the sink and the floor drain of the operation. This photo on the left, a correctly installed sink typically has two air gaps: the air gap between the flood rim of the sink and the faucet, and the air gap between the drain pipe of the sink and the floor drain. Grease condensation and leaking pipes. Grease condensation in pipes is another common problem in plumbing systems. Grease traps are often installed to prevent the buildup of grease from creating a drain blockage. If used, grease traps must be easily accessible. They must also be installed by a licensed plumber and cleaned periodically according to the manufacturer's directions. If traps are not cleaned or are not cleaned correctly, a backup of wastewater could lead to odor and contamination. This photo on the left, a grease trap on the floor of an operation near a sink. Grease traps are often installed to prevent the buildup of grease in drains. Overhead wastewater pipes or fire safety sprinkler systems can also leak and become a source of contamination. Even overhead lines carrying drinkable water can be a problem. Water can condense on the pipes and drip into food. Check all pipes often to ensure they appear in good condition and do not leak. They should be serviced immediately when leaks occur. For sewer, sewage and wastewater contains pathogens, dirt, and chemicals. It is absolutely essential to prevent them from contaminating food or food contact surfaces. If there is a backup of raw sewage in the operation, the affected area should be closed right away. Then the problem must be corrected and the area thoroughly cleaned. If the backup is a significant risk to the safety of food, service must be stopped. Then a local regulatory authority must be notified. The facility must have adequate drainage to handle all wastewater. Any area subject to heavy water exposure should have its own floor drain, and the drain system should be designed to prevent floors from flooding. Lighting intensity, or how bright the lights are when in the operation, is usually measured in units called foot candles or lux. Different areas of the facility have different lighting intensity requirements. And regulatory authorities usually require prep areas to be brighter than other areas. This allows staff to recognize the condition of food. It also helps staff identify items that need cleaning. Lighting intensity requirements are shown on Table 11D, and contact the regulatory authority for requirements in your jurisdiction. Table 11D, minimum lighting intensity by area. 50-foot candles is required in prep areas. 20-foot candles is required in hand washing and dishwashing, buffets and salad bars, displays for produce or packaged food, utensils storage areas, wait stations, restrooms, and inside some pieces of equipment like reach-in refrigerators. 10-foot candles is required inside walk-in coolers and freezer units, dry storage areas, and dining rooms. For cleaning, once the correct level of lighting has been installed in each area, you need to monitor it, replace bulbs that have burned out, and make sure they are the correct size as well. All lights should have shatter-resistant light bulbs or protective covers. These products prevent broken glass from contaminating food or food contact surfaces. And ventilation improves the air inside an operation. It removes heat, steam, and smoke from cooking lines. It also eliminates fumes and odors. If ventilation systems are not working correctly, grease and condensation will build up on walls and ceilings. To prevent this, clean and maintain ventilation systems according to the manufacturer's recommendations and your local regulatory requirements. For mechanical ventilation must be used in areas for cooking, frying, and grilling. Ventilation must be designed so that the hoods, fans, guards, and ductwork do not drip onto food or equipment. Hood filters or grease extractors need to be tight fitting and easy to remove. They should be cleaned often, and the hood and ductwork should be cleaned periodically by professionals as well. Your garbage can attract pests and contaminate food, equipment, and utensils if not handled correctly. To control contamination from garbage, consider the following. For garbage removal, garbage should be removed from prep areas as quickly as possible to prevent odors, pests, and possible contamination. Staff members must be careful when removing garbage so they do not contaminate food or food contact surfaces. This photo on the left, this food handler is tying off a garbage bag set on a prep table, contaminating the surface of the prep table. Cleaning of containers. Clean the inside and outside of garbage containers frequently. This It will also help reduce odors and pests. Do not clean garbage containers near prep or food storage areas. Indoor containers. These must be leak proof, waterproof, and pest proof. They also should be easy to clean. Containers must be covered when not in use, and women's restrooms must include a covered receptacle for sanitary napkins. Designated storage area. Waste and recyclables must be stored separately from food and food contact surfaces. The storage of these items must not create a nuisance or a public health hazard. Indoor containers. Place garbage containers in a surface that is smooth, durable, and non absorbent. Asphalt and concrete are good choices. Make sure the containers have tight fitting lids and are kept covered at all times. Keep their drain plugs in place. The photo on the left, a dumpster set on a concrete slab, which is smooth, durable, and non absorbent. Knowledge checks. Pause and answer these questions. Question 1. What risk do backflow and backflow siphonage present to food safety? Question 2. How does proper ventilation improve the air inside of an operation? Chapter summaries. Plan for new construction or extensive remodeling must be reviewed and approved by a local regulatory authority and a local building department. Choose flooring, wall, and ceiling materials that are smooth and durable. This will make cleaning easier. Replace and maintain these materials when necessary. And make sure equipment that will come in contact with food is smooth, non-absorbent, and easy to clean. Floor-mounted equipment must be put on legs at least 6 inches high or sealed to a masonry base. And tabletop equipment must be put on legs at least 4 inches high or sealed to the countertop. Dishwashing machines must be installed so they prevent contamination of utensils, equipment, and other food contact surfaces. Hand washing stations are required in areas used for food prep, service, and dishwashing. They must be used only for hand washing and should never be blocked for use. Hand washing stations should include hot and cold running drinkable water, soap, and a way to dry their hands. They should also include garbage containers if paper towels are provided, and signage reminding staff to wash hands before returning to work. Plumbing must always be installed and maintained by a licensed plumber. This will prevent cross connections from occurring. A cross connection is dangerous because it can let backflow occur. Backflow is the reverse flow of contaminants through a cross connection into a drinkable water supply. The best way to prevent backflow is to avoid creating a cross connection. Vacuum breakers, double check valve backflow preventers, and reduced pressure zone backflow preventers can all be used to prevent backflow. However, an air gap is the best way to prevent backflow. Garbage must be removed from prep areas as quickly as possible to prevent odors, pests, and possible contamination. Garbage containers must be leak-proof, waterproof, and pest-proof. They must be cleaned inside and out frequently. Facilities must also be regularly maintained. Clean them on a regular basis and make sure there are no leaks, holes, or cracks in the floors, foundation, or ceilings. Pause and ask yourself your discussion questions here. You should have something to say about each one of these discussion questions as they link back to the learning targets of the chapter. Pause and apply your knowledge. Go or no go. Apply your knowledge. Where's the smoke? And stop and answer the study questions created by your test writers to help you get practice and check your knowledge.